Hi guys, so we'll be seeing today the smart contract for the dNFTs, and that smart contract will be using the data from the Shamba Oracle for for the air quality data set. So let's actually here is the repo for the same. You can just clone that and then you will get a structure like this in your VS Code, and let's see what's inside this, like air quality dnfts.sol in the contacts folder. So here you will see that, so actually it's basically a ERC 721 contract, just like we have added some functionality of our own, which is to basically interact with the Shamba Geospatial Oracle, and also the the IPFS URI for the animation GIF that we are using in this. So in the IPFS URI, we are using an array of strings, which is pointing out to four different IPFS URLs that are basically stored into into the Web3 storage of Shamba. And here we are having one into 56 data, which is named as geostats, and it's having the data that is returned by the Shamba Oracle, like it will store that data in it. And so you can see we are having check geostats function, and along with that, so the check geostats function is the one which is basically sending the request to the oracle with the parameters. We'll be passing this parameter using the Python script request geostats data, and here are the normal functions like the get latest CID, which is to get the CID from the oracle, to get the latest CID of the oracle. The CID means the content ID of the metadata, and here we are having the get Shamba Geostat data function, which is to retrieve the latest data returned by the oracle. And here we are having the typical function of any NFT, which is safe mint. So it's basically minting the NFT for the very first URI, which is just no data GIF, which we are using here, no data JSON. And so it means that if there is no data returned by the oracle, so then it will just point out to this, the first index of the IPFS URI. And like after we call update NFT, then it will just check whether the data is non-zero. So zero means no data. Since zero means no data in Solidity, so that's why we are checking it. If it's non-zero, then we are checking it for the different categories, like if it's less than or equal to 0.3 into 10 raised to the power 17, then it means that the air quality is good, and we are just changing the URI to point to the first index. And in another condition, we are checking it if it's greater than 10 raised to the power 17. So you can make your own conditions also. We have just tested out for some of the conditions, and that's the best we can come up to, in order to show our test case to you. Basically, we are using this. You can change the conditions according to the use case. Like, since we are using it for air quality, that's why we are using such ranges by testing the data for some places like Zurich, Switzerland, which is having a good air quality mostly, most of the times. And we have also tested for New Delhi, which is having the bad air quality most of the time. So that's why it's according to those test cases that we have done. So we come out with these particular ranges for the same. And here we are checking the as condition, which is the bad air quality one, and then we are setting the token URI corresponding to that. So that's all for basically the air quality dNFT.sol. And like I forgot to mention that here we are importing the Shamba contract, which is from the Shamba official smart contract kit. Like you can see it from there, this one. Like we are importing the Shamba smart contract kit right there. And so you can see we are using, like inside the contracts, we are using the Polygon and the Mumbai testnet folder. So you can navigate to the same, like in the contracts. Then there are two folders, basically Ethereum and Polygon. Then you can come inside the Ethereum. No, you can come inside the Polygon one, and then from the Polygon one, you can just navigate to the Mumbai testnet one, and that's what we are importing right there. So yeah, so we are using the Shamba Geoconsumer contract from the Mumbai testnet folder that we have just navigated into right there. So that's basically a Shamba Geoconsumer contact, which is basically sending the request to the Shamba Oracle for us. So that's why we are importing it, and we are reusing the functions of that in terms of request geostats data and in terms of get CID and get geostats data. So basically, you can just import that contract like any contract from Shamba official smart contract kit and then just reuse the same and build the logic according to your use case after getting the data. And now let's deploy this. So in the deploy script, we are just deploying the smart contract as the name suggests. So brownie run script slash deploy .py, and the network is Polygon test, as I mentioned earlier also, because that's what we use for dNFTs. So the contract is getting deployed now. So after deploying this, you can verify that to publish the source of the contract, like to publish the source code of the smart contract to the Polyscan, basically Mumbai Polyscan, like we did for the Ether scan for the previous cases. Now we'll be doing everything on the Polyscan, and so the deployment is done. Now let's proceed with minting the dNFT because I have already verified it. So it will just show that it's already verified for me. Let's just call mint dNFT.py. So it's basically calling the safe mint function from the air quality dNFTs that I have just shown to you. The safe mint function right there using the address parameter, and the address is our basically the MetaMask wallet address. So just run this script. So the safe mint is successfully called. So our dNFT is minted. So our dNFT is successfully minted. So now you can basically take the deployed address by copying it and just come to testnets.opensea.io, this link, and here you can search your NFT with the address. You can see we got the air quality dNFT right there. So yeah, you can come inside this. So here basically you are seeing that we are having no data, like the title is no data. So it means like we are still on to the very first index of the dNFT, which is pointing out to the no data emoji.json. So, and here you can see the description of that we had set for this, a confused smiley representing that the dNFT state hasn't been updated yet. And here are the properties, which is like confused. So it's basically representing that the update state hasn't been called yet. Like the it's not having any data from the oracle received yet because we haven't called it yet. So let's check it by calling that. So before calling that, we have to call the request geostats data function to send the request to the oracle to return the data to us. So let's call request geostats data.py. So it will basically send the request to the oracle. So let's check it what we are doing in the. So here we are having three test cases. So we are just checking it. Like we have already tested it, so we know the range that will come up. Like so, we are checking it for a particular location. Like so, the location is of basically Zurich, as I already mentioned. These coordinates are from Zurich location. It's in Switzerland, and yeah, we are checking it for second and third June. Like for the second June, it's basically a start date and it's basically an end date. So we are checking it for second June, and the data set we are using, then use the same, and that's basically a selected band that we are using. Like we will just check for all the three states. First, let's check it for the first one, which is the good air quality. So let's check what's the data returned by the oracle by calling the get geostats data function. So you can see here it's starting from 255. So it means that it comes in the first range that we have defined right there in the update dNFT. So we are checking it if it's less than or equal to 0.3 into 10 raised to the power 17. It means that after 3 it should have 17 zeros. So you can see that after 2 it's having 17 digits. 1, 2, 3, 4. Not 17 actually, 15. Because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah, actually 16 because it's 0.3. So it's 3 multiplied with 10 raised to the power 16 and 0.3 multiplied with 10 raised to the power 17 means the same. So it's basically falling into this category. So like if we update our dNFT state just now because we are having this in the current geostats current geostats parameter, like the variable. So if we just update the state now, so we will receive that the air quality is good and it will just point out to the first index of the IPFS URI, which is basically pointing out to the good air quality.json right there. So we're basically checking it for this now by calling the. So now we'll be calling the update dNFT. So the update dNFT is basically calling the update dNFT function from the smart contract that I have just shown to you previously. Update dNFT is basically having this body right there. So here we are having two parameters. One is new URI parameter, one is token ID. So here we are getting the current geostats from the Oracle by calling the get geostat data function that I have shown previously, and now we are comparing it with zero first. Like if it's non-zero, then only we'll be proceeding to change the state. Like if it's zero, then it means no data. So that's what our state is being pointed to just now, which means that there is no data. So we are comparing it with zero first. Like if it's non-zero, then we are checking it whether it's less than or equal to this certain value, and that we are checking it if it lies within certain range for the intermediate, and then we are basically, if it's not lying in these two, then it will just come up into the else, which is the bad air quality. And the index are basically in the sequence, like for the good it's 1, for the intermediate it's 2, and for the bad it's 3, and for the no data it's 0. You can see right there. No data 0, good 1, intermediate 2, bad 3, 0, 1, 2, 3. So let's call the update dNFT now. So yeah, we are calling it for this data that's being returned from the Oracle for the first test case. So update dNFT. Yeah, let's just call it. So you can see it's being confirmed. Now let's get back to our dNFT on OpenSea, and then we just need to refresh this from there, and let's just wait for a while, and then just refresh the tab. So you can see we are having the metadata as good air quality, and we are having this emoji for the good air quality. So you can see, you can read the description right there. A happy smiley representing the good air quality in the environment. And the properties, the traits of this is basically good, and the property is happy. So you can read about these properties. Yeah, basically like it will show all these properties right there. And now we'll be checking for the other use cases by requesting for the same. So we will just comment this one out that we have already tested, and now we'll be testing for the intermediate one, which is New Delhi. Like the coordinates are from the New Delhi location, and the dates you can check right there. It's 5th June. Start date is 5th June, and the end date is 6th June. Rest everything is same. Like only the coordinates and the dates are different. So let's save it first. Now we have to request geostats data. We have to call request geostats data. So yeah, every transaction. So actually, every calling to request geostats data require one link to be sent it to the smart. So here you can see one token is being sent. So basically request geostat data require one token because that's the function which is making the call to the oracle by sending the request to the oracle. So the oracle needs one link to be funded before making a successful call to the same, and after that we are calling the request geostat data function like here. So actually you can see in line 6 and 7 we are transferring one link to the oracle, and that's the Oracle contact address for Mumbai testnet. You can cross-check the same by navigating to the Chainlink website for the link token contract. And let's just basically call. So we have already called the request gesture data. Now just check it, check the value being returned by calling the get gesture data. So you can see we are having two CIDs now. It means the first CID is for the previous call that we have made for the good air quality value, and now it's for the intermediate one. So you can see the value is 385. So starting from 385, you can see by checking it. So it's basically greater than 0.3 into 10 raised to the power 17 and less than 0.4 into 10 raised to the power 17. It means that it lies here. So it lies in the intermediate air quality, and it will point out to the second index. Yeah, so like when we just call the update dNFT, then it will just point the dNFT to the second metadata, second the metadata at the second index of the IPFS URI. Let's just call the update dNFT. So the update dNFT is being confirmed. Let's head back to the OpenSea. So here it's still showing good air quality because basically what OpenSea used to do is like it basically used to cache. So actually it's basically cache the state of the dNFT right there. Like unless you refresh it explicitly, it will not show you the updated state. Like it's for its own use case, like for its own performance use cases, it basically used to cache the metadata. So we have to refresh it, we have to refresh, we have to reload the page. Now you can see the metadata is being changed to intermediate air quality, and the GIF is also being changed, the emoji, the smiley, and you can see the description here, a smiley having a face mask representing the intermediate air quality in the environment. And here are the properties, intermediate and the mask. So yeah, that's for the intermediate one. Now we'll be checking our last condition, which is for the bad air quality. Now let's get back to our request usage data file and comment out this request that we have just made for the intermediate one, and let's just uncomment the last one, which is for bad air quality. Like the bad air quality is also having the same location, which is of New Delhi, coordinates of New Delhi, but the dates are changed. You can see here we are using the 5th and 6th. The 5th is the start date and the 6th is the end date. So here it's 3rd and 4th. So the start date is 3rd June and the end date is 4th of June. So it means that for that particular date, we should be having the bad air quality. Like we have already tested that value range. It will come out to be bad air quality. Now we'll be testing it again to confirm in front of you basically while recording the video. So now let's just save this file and just call it for this particular test case now. So just call the request data.py after saving the file right there. So the request is being confirmed. So we'll be checking it now. Basically, let's check it by calling the get geostats data. Yeah, we are having three CIDs now, one for the good air quality that we have called for the first one, and then for the intermediate that we have called for the second test case. Then this the latest one, which is for this particular use case of bad air quality, and you can see the data that it returns is 464. So you can just check back in the air quality dNFT.sol contract that, so like it's not lying in any of these two ranges, so that's why it's falling into the last category, which is of bad air quality, because it's greater than 0.4 into 10 raised to the power 17, because it's starting from 464. So now let's just call the update nft.py right there. So update NFT is being confirmed. Let's get back to our testnet OpenSea.io and just refresh it, refresh the metadata right there, and you have to press the refresh. You have to reload the page, and you can see we are having the bad air quality metadata title, and here we are having a sneezing emoji. So here you can read the description also: a sneezing smiley with a face mask representing the bad air quality in the environment. And here you can see the property. It means bad, bad means bad air quality, and sneezing and basically masked. You can see, you can read the full property, sneezing and masked. So yeah, so we have just tested three for all the three use cases by calling the respective location coordinates and the date values. You can just test the same for your own use cases, like basically by changing the dates and playing around with it by selecting the coordinates. You can select the coordinates using the context tool right there, context.shamba.app. Like you can draw any coordinate in any location, and it will just show this kind of coordinates object to you. You can just copy this and paste it right there as we did, and then just test it for particular dates or whatever you want to test, and then by sending the request first, and then you can check whether the data is being received yet or not by calling the get geostats data, and then you have to just call the update dNFT so that it will update the state of the dNFT according to the use case that you have been called. So that's all regarding the dNFTs.